This is a video on how to replace a Danfoss high pressure humidification pump, a live system that's running, specifically this system. This particular pump has been in operation for around 18,000 hours and has developed some noise and pumping capacity issues. Basically, I think the valve plates are worn and it cannot create a good discharge anymore. Plus, there is a bit of noise when it is running, some type of knocking. So we're going to replace this with a new pump, and then we're going to take this particular pump apart that we see right here, this pump here, and inspect it to see if we can see really what's wrong with it. That may be in a separate video, but we'll do that also. Now this particular pump should have lasted longer than probably 18,000 hours, but it did go through some abuse in its early stages of its life. The water supply to it is gravity fed, and so there's not a lot of pressure to the suction side of the pump. So there were some times when it didn't get all the water that it's supposed to get, and it got some air within the lines during startup, and other times that caused the pump to cavitate quite a bit, could have deteriorated its life expectancy. Now, while I was repairing this pump, I actually did some live video of me, digging into it and repairing it. So that's going to be included in this video, and I'll prepare you before I start that portion of it. And there were some other issues that I found out, or some problems that I found out while I was repairing this pump, besides just the pump being bad. So you'll see those as we go along here. But this is the pump itself right in here. This is the bell housing that has a coupling in it. This is the motor, and it's got a shaft in there, and then there's a coupling that couples the pump to the motor, and you'll see that for a little bit. But this is what we're going to be replacing. It's got two lines coming in and going out of it. You can see here's one. It's a stainless braided stainless steel line. That's actually the input water to the unit, and then this hydraulic type hose right here, that's the output water or high pressure side. As you can see, when this picture was taken, it was running around 1,000 psi. In fact, it's right at about 1,000 psi. But on the input side, this is a gravity fed tank. Now this gauge is a compound gauge. That's not the way all systems are, but on this particular site there are 3 systems that run off this gravity feed and have compound gauges in it. So this gauge is actually showing about 2.5 psi, because that tank is up about 12 feet in the air, and I'll show that to you here right now. So this is the holding tank that contains the water that's fed into this pump. It actually feeds 2 pumps. No, actually it feeds 3 pumps, excuse me. These 2 lines that we see coming back here are the bypass lines from the pump. It might be a little hard to understand, but this is bypass water coming back to the pump. And here's one of the problems that I'm gonna show a little bit on the pump that I'm repairing. This line is a little dark, and we'll get into why that line is dark and dripping in here. You can see that this other one is light and pretty clear, and there's nothing wrong with it. So that's the tank. And this is the back side of the tank. It's actually got 2 proxy sensors, I think is what they're called. One here, one here. And if the water in this tank gets too high or gets too low, it will send an alarm to the building automation system to tell them that there's something wrong with this tank. This is a drain valve here. And this has been in operation for about 2.5 years now and hasn't had any problems on it. On the other side of the tank, which we'll see shortly, there's a couple of valves that regulate the water into the tank. I'll show you those here right now. This is the other side of the tank, and what we've got here is 2 supply lines into the tank. This one right here, and this one right here, and then the drain, and then the drain. It's not a drain, but it's the water supply going out of the tank into the humidifiers, the suction side of the pumps. So this line right here is deionized, pure deionized water from the customer, and then this one here is city water coming in. But this city water is regulated by a sensor, a water quality sensor, or a It reads microohms or microsiemens, the quality of the water. And it's this cable right here. So that comes in there and actually senses how clean the water is. And if it gets too clean from the pure deionized water, it actually opens up a solenoid valve where this line comes from and lets a small amount of city water into it to dirty it up a little bit. And the actual flow of it is regulated just by this ball valve here. You can see that it's cocked a little bit to indicate that it's restricting the flow a little bit. And each one of these go into a float valve. So there's actually, it's quite a large float valve with a polypropylene ball on it, a stainless steel valve assembly. I don't have any pictures of that, but there's two of them here, one off this one, one off this one. So this one really keeps the level of the tank at where it's at right there right now. And this one just feeds a little water into it, calls for it. And here's a picture of the microohm meter. You can see it says it's 4 microsiemens right now. And it comes on at 3 microsiemens. You can see again it says 4 microsiemens right now. So as soon as it gets to 3 microsiemens, that solenoid opens up and slowly adds a little city water into that tank. And then as soon as it gets up to 5 microsiemens, it shuts back off again. And even there, at 5 microsiemens, it overshoots somewhat. So turns on at 3, shuts off at 5, but a lot of times it might go to 7, 8, or 9 microsiemens once the water in the tank is fully distributed, or that's not the right word, but evened out within the tank. It rises a little further. And then water feeds out of it into the pumps, and it goes back down to 3 microsiemens and starts that process all over again. Now you might ask why we're doing that, and that's another long story, but I'm going to try to make it short here, and that is that if we don't dirty up the water a little bit, when the mist comes off the nozzles, it will collect on the nozzles and the piping itself if it is pure DI water. Since it's so pure, it wants to go back and collect some minerals off the water. So it just goes back and it a little bit adheres to the pipe and it drips. If we dirty it up just a little bit, it won't do that. And with this particular environment, we have to do that. We have to dirty it up a little bit. So this works quite well, and it's like I said, it's been in for 2.5 years, working fine. We'll continue on. So that was quite a lengthy jog away from what we're primarily trying to do, is to change this pump out. But I wanted to cover that for the main viewers to get a little bit more background on this system. Now, this is a interesting picture. This is a different picture. This is the picture when it is completed, when it's already, the pump has been replaced. And there are some differences. This particular water regulating valve here is different. There's a check valve in here, and so it's set up a little differently. I'm going to find the picture of before I repaired it right now so you can see the differences. So take a look at this right here, and now take a look at this. And the differences are this again, like I said, this water regulating valve, and then this line right here got changed out. And we'll see a little bit more as we continue on why that got changed out. So what I'm going to do now is start to repair this, actually start to take it apart. And what I said earlier is I took some live videos while I was doing this, so I'm going to begin some of those videos right now where I start to dismantle this pump. So I'll be in and out with videos and explanations with pictures throughout the rest of this. So here we go.
Okay, we're going to begin the repairs here. First thing we're going to do is to shut off these valves, both input and discharge. The unit is shut off, and then we got to disassemble this assembly here. So the first thing I'm going to point out is, what connections are easy to take apart and what connections are a little bit more difficult to take apart. So any connection that is an NPT, National Pipe Thread Fitting, is a little more difficult to take apart. And any connection that is a union like this or a compression fitting like this are easy to take apart. So probably what we'll do first is we'll take apart these compression fittings first to get the hoses loose, then take the hoses off, and then start to disassemble some of the other. So we'll come up here, take off this compression fitting, see if I can get it loose with one crescent wrench, and I can. We're going to have a little water dripping here. That one okay. And we'll take off this one. There's that. Now we will see whether, well, we'll take off this one, which is actually the bypass line also. Oh, we got water coming out of there. Can't have that. Let's put it back together here for a minute. Well, now I think about it, it's just going to go as far as that line. So let's take it off there and we'll let it go, because it's not going to go forever. All right, so now we'll take apart this hose assembly here. I think we'll get two crescent wrenches on it. So I put this one like this. Get it the right direction. Well, here's something. You can see it started to, maybe we don't have to do that, because this fitting right down here on the pump, since this pump is made in Denmark, it is a British threaded fitting, and this happens to be a British parallel threading, a BSPP, British Standard Parallel Pipe Thread, and it has an O-ring or a gasket on it, so we can actually take this and unturn it with the hose on it. A little water on the floor. I did bring some rags here. Fortunately, I am getting a little wet, but we'll mop some of this up. Stop the video for a second. Now that we are recording again, we've got the suction side that we're going to take out. Now this has got this fitting in it here that's not needed, so we'll end up removing that when we put it back together. This was kind of the part of the bypass that we had at one time. And now the hose assembly itself, we'll see if we can get this apart. There we go. Now, since this is a British Standard Pipe Thread 1/2 inch, and the bottom of the pump, suction side of the pump, that will unscrew quite easily. Now I decided I'm not going to take that out for now. Now I'm going to just disassemble the pump. There's actually 2 bolts that hold this pump together. One here and one on the back side. probably not going to be able to see this with the camera very well. In fact, it might even be too dark. But once we get it apart, you'll be able to see it. Okay, I got that bolt out of there. Now you can see down here, you should be able to see it. I'm going to go right above it here. There's a coupling down here. It's a Lovejoy coupling. And we'll see what kind of condition it is, whether we're going to save it or not. Probably is in pretty good shape. There is the one part of the coupling. We'll take a look at the rubber coupling part of it. That's in really good shape too, so there's no need to change that out. Hardly looks like it's a bit worn with 18,000 hours on it. We'll put it back in.
So we're back at the completed picture here again. I'm going to show another video, but a lot of things happened between the two videos. I got this pump on and I got the bottom fittings on, and then I'm going to start to explain some further repairs that I had to make. Specifically, I had to change out this water regulating valve here from the old one to this new one, and then change out this hose right here. And you'll see within the video why, but there's a pretty good jump between videos, and I just wanted to put this little piece in there to explain it.
Okay, quite a few things have happened since I started spilling some water. As you can see, I did get the pump out after those 4 bolts, and this is the old pump, and I was redoing the input piping. This is the input piping for the unit, and I wanted to redo that because it had some fittings in there that were from some original pump and some things. So I'll just say things changed. So here's what I put in. You can see we've got a 1/2 inch BESPP to a 1/2 inch NPT, 1/2 inch elbow, 1/2 inch reducer to a 1/4 inch input line. Now, 1/4 looks small, but boy, this pump just doesn't take very much water, and a 1/4 inch line is sufficient. So there's reasons why this is a 1/2 inch on this pump, because this is actually the smallest pump that they make. They make a pump, same configuration, same casing and things, that does about 4 times as much water. And then we'd probably go to a 3/8 inch or a 1/2 inch line to feed it, but this 1/4 inch line is fine. So I changed this up to get rid of, these fittings here. But I did discover one thing, and that is I'm going to have to change out this hose. Here's the new hose I'm going to put in. This is a braided stainless steel, and it has a Teflon lining in there, which is good for DI type water. Now, this is not DI water, but it's close to it. It's probably high grade RO or DI, and this hose is breaking down internally. This hose is a hydraulic hose. Generally, they have a synthetic rubber lining in them, which is pretty much good for DI water. However, I'm realizing that this one is not good enough, and it is breaking down. If I put my finger in the discharge port, you can see this black stuff come out on my finger, and that's the breaking down of the hose. So this hose is not good enough, and we're going to have to change that out with this one right here. Now, this was a 1/4 inch hose. I'm actually going to go to a 3/8 because I got to put a couple of fittings on it, but that's what I've got right now, which is fine. So we're going to change out this hose. Now I do want to show you one other thing, because this ends up being a training video for the owner of this pump. This hose I can't see any of the designations on it on what kind of hose it is. But another thing that clued me in that this hose is being contaminated is this particular discharge line right here that goes up to the tank. Once it gets to right here, you can see that it's a little colored. It's got a yellow color to it, and if we go up a little further, you can see that it's got a yellow color to it. But if we take a look at the other pump that's coming into it, there are two lines. There are two pumps going into this tank right up here, and that one of them is quite clear and the other one is cloudy, and the one I'm replacing is the cloudy hose. So that's the hose that actually has the hose that's breaking down. Now if I come over here to the pump that has the clear hose in it, and we can take a look at this, and you might be able to see it because it's kind of dark here, but here is the clear hose. And this pump is running right now. It's discharging a little water through it. But let's take a look at the high pressure hose here. Right here, this is a SAE 100 R2A2T. It's about it's a very high pressure hose. Let's see if we can see. 5,800 PSI, and we're only doing 1,000 through it. But I happen to know that this hose, this SAE 100 R2AT, does have a synthetic rubber lining in it that is supposedly good for DI water. And as we can see here, it probably is good for DI water because it's clear. It's not breaking down at all. So I wanted to point that out and show you that why I'm replacing this hose. Now I'm going to also replace this regulator. Again, I'm going to look at it. I'm going to replace this regulator, but I don't have one with me. So we're going to stop this repair as of today. It is not needed. It's kind of a standby unit. But I'm going to put a new regulator in there and put this new hose in there next week and get it back together. But I am going to put some of it together here today to at least get part of it done. So I just wanted to show you that much, and that's it for now. Okay, I got it as far together, excuse me, as I can today. And I went over this piping, but here is my discharge piping. We've got a BSPP 1/4 inch fitting that goes into the pump, and then that adapts to a 3/8 inch fitting, and then this is a 3/8 inch branch T, and it's NPT, National Pipe Thread. So we got 3/8 inch female on this, 3/8 inch female here, and a 3/8 male here. And then here we have a check valve, and we had to have an adapter in between because this check valve is female on both sides. So this is a high pressure check valve. We'll only let the high pressure water go one way, we won't let it come back. And then we've got this adapter in there. Then this is the high pressure hose that I talked about, it being a Teflon, the inner lining is Teflon and stainless steel rated. So it's rated for about 2,200 PSI, and it'll come up here and go onto here. And this is the fitting I need. I need a 3/8 inch adapter to go from pipe to tube, and then I'll go in there. And then on top of here will be the new water regulating valve, which will regulate the pressure at 900 PSI when we're at minimum RPM on this pump. And then this line right here will come off and go into the new water regulating valve as far as the bypass is concerned. So that's it for today, and I will continue next week, next Monday, when I get some more parts. Signing off. Bye.
So this is the completed project after I've replaced the pump. So we have a new pump here. We have a new discharge line with a check valve, and we have a new regulator here, plus some new fittings on each side. So I've also changed out the hose. This is the bypass hose that brings the bypass water back into the holding tank above this unit. And here it is, a clear line again. And here's a picture of it at the tank with the clear line that I replaced. I replaced the little piece right here too, and here's the existing clear line that came from the other pump. So that's that. So in order to get this unit back up running again, I had to do some bleeding, bleed some air out of the system. And the way you do that is first you open up the incoming water supply line, which is this one right here. Slowly open it up. Then there's a small little plug right here on the top of the pump. It's an air bleed port, and it takes an Allen set screw of 4mm, and you loosen that up and you let the water bleed, bleed the air out through this line and up through the bottom of the pump and up into here. For this particular setup, that's fine because the bypass water, when the bypass is running, goes into a tank. You've seen that tank up above, and if there's any air in that line, it goes into the tank and escapes that way. However, I did crack this particular nut right here to bleed when this valve was still closed. It's a discharge line out to the nozzles. I cracked this nut right here when I started running the pump at first. So the pressure built up, and there's a bypass water going out here, and then a little air came out of this nut, and then it started dripping a little water, and I tightened that nut back up just to get a little air out of that discharge line. And then I opened up the discharge line ball valve and opened up a solenoid valve in a test mode and checked the unit out. It seemed to be running good. It's nice and quiet, just like a new pump should be. So that concludes this video. Look for more in the future. Thank you very much.